Ladies and gentlemen, welcome back to Wednesday night watching. So today we're looking at a very basic introduction into the concept of identifying a quadrilateral not given the shape itself. Holy cow, what are you going to do? It's crazy. It's crazy, crazy, crazy. But to review first. Oh, try again. Slide down. Here we go. We're going to review a couple key concepts. We've got the distance formula, the slope formula, parallel slopes, and perpendicular slopes. So, unfortunately, I think, we got a little bit of a mistake here. This is going to be crazy. So, with that, and I have no idea if you're seeing this, I'm readjusting my screen right now, so I can't tell if you can see this or not. But so, the distance formula, you should be thinking about what the distance formula is right now. Okay. Well, the distance formula is good. Yep, it starts with the square root of x2 minus x1. And what do we do with that number? Well, we're going to square it, since we're dealing with distance, plus y2 minus y1. And we're going to square that too. Good, that's the distance formula. Slope formula, we know that's y2 minus y1 over x2 minus x1, or better known as rise over run. It's awesome. How can we tell if we have parallel slopes? If they're parallel, that means they're going the same direction. That means that they have the same slope. And last, but absolutely positively not least, is whatever's on the bottom. Perpendicular slopes. So that means they're going not completely an opposite direction, but perpendicular means they're intersecting at, what is it? Okay, good, 90-degree angles. So that means the slopes probably need to be opposite. And we're going to flip, the slope has to be flipped, and that's reciprocal. So remember, what opposite reciprocal means is that, say our slope is 2. So that means our opposite reciprocal would be, so the perpendicular slope would be negative opposite reciprocal 1/2. Okay. So I'm going to show you one example of this problem today and how we're going to use it, and then we'll get a lot more into it come our block day. So here it comes, ladies and gentlemen. Bang. What type of quadrilateral is this? Close. Get out of there. We just want to see it. Just want to see it. Let me see it. I got to move it out of the way. Okay. So we are given, bang, 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 4 coordinates. We're not going to look at this on the coordinate plane. You know, actually, we forgot our coordinate plane. I don't know where it went. So we need to identify what kind of a quadrilateral is this. Well, let's talk about properties here for a second. So in order to identify different shapes, what kind of things are we looking for? Well, we want to check parallel lines. So that's going to tell us, so if we have parallel lines, what kind of a shape do we have? Well, we're going to have a parallelogram. Or, as I call them, and you know this, or one of the big 3. And the big 3 would be rhombus, rectangle, square. Okay? If they're not parallel, then that would leave either the kite or, good, the isosceles trapezoid. What if we have one set of parallel lines? Well, one set of parallel lines would give us the isosceles trapezoid. And no parallel lines would give us a kite. And then we have things that we can deal with congruent sides. So the first thing we're going to do, let's see at the slope of each. We have PQ, we have QR, and these are each sides. Because think about it, we have PQRS. So PQRS is this quadrilateral here. We don't know any properties that PQ, that'd be an R right there, RS would have. So we need to look at, we have PQ, and then we have QR, then we're going to look at RS, and then we want to look at SP. So the first thing we want to do is find the slope of each. So we want to find the slope of PQ first. So I want you to pause this for me. I'm going to trust you to pause it and find the slope. You should have gotten the slope to be 1/2. 9 minus 7 is 2. 5 minus 1 is 4. 2 divided by 4 is 1/2. Slope of QR. If we look at QR, y2 minus y1. So we've got -6 over 3 minus 9 is -6 over 3. So the slope would be -2. So now let's get the slope of RS. 1 minus 3 is -2. 4 minus 8 is -4. Well, that equals 1/2. Ooh, that's interesting. So right now we're looking at, we have got two congruent slopes right now. Now we got SP. Well, that's SP. So 7 minus 1 is 6 over 7 minus 1 is 6. 1 minus 4 is -3. So that gives us a slope of -2. Well, now look at this. We've got -2 and -2. So we for sure know that PQ and RS, so we have PQ and RS, we know that those two are parallel because their slopes are congruent. We also know that QR and PS are also parallel. So we know we're in the big 3 category right now. What's another thing we could figure out? To see if we're in the big 3, how can we determine it? Well, what if we compare the slopes of PQ and QR? If we look at PQ and QR, so we're going PQ and QR, PQ is 1/2 and QR is -2. Well, what does that give us? PQ and QR would be perpendicular. So those are 90-degree angles. And if we look at every single one of these corners, they are going to be 90-degree angles. Wow. So now that we have 4 90-degree angles, what are the only 2 shapes it could be right now? Correct. It's either a square or a rectangle. How are we going to determine if it's a square or a rectangle? How are we going to figure out the lengths of the sides? We're going to use the distance formula. So what I'm doing, if this is me, how can we tell if it's going to be a square or rectangle? We're going to compare consecutive sides. Because if it's a square, all 4 sides are congruent. If it's a rectangle, only the opposite sides. So we're going to compare PQ and QR. We're going to use the distance formula to compare PQ and QR. If they're the same, it's a square. If they're different, it's going to be a rectangle. The online quiz is up right now. Your answer is simply choosing, is this a square or a rectangle? Finish this problem. If these 2 are the same, it's a square. If these 2 are different, it's a rectangle. See you in class. Be safe.